Alright, so for today we're going to talk about equations of circles. We're going to go through kind of a similar process as before with the parabolas, but now we're just going to focus on circles. So the nice thing about circles is that they are even less things to have to figure out. You got to figure out only really two things to be able to graph a circle. And then after that, we will practice writing equations for different shapes in the next two lessons. So here we go. So remember, the definition of a circle is actually just a collection or set of points in a plane that are all the exact same distance from a singular point. We call that point the center. So when you look at a circle and the actual kind of curvature and kind of drawing of a circle, it's actually just all those points put together that are all the exact same distance from that center point. Remember the distance then from the center, that's what we call the radius of the circle. And then to throw in here also, remember that twice the length of the radius, or 2 radii, plural, radius plural, 2 radii put together would be the diameter of the circle. But remember just the general kind of terminology we use with circles, but now let's talk about the actual equation. So the equation of a circle is going to highlight and point out the center and the radius of the circle. So the actual form for the equation of a circle, just in general, the format for it is going to be x minus h quantity squared. So again, it's kind of like similar to seeing x minus h back in vertex form, plus y minus k quantity squared, and that is going to then equal r squared. And so a few things to point out here. Your center is located at h comma k. So the center of the circle is located at hk, and the radius of the circle is simply just r. So notice that r squared is at the end there, so you're going to have to take the square root of that number to figure out your radius. Okay? Remember here to be careful, just like we did before with identifying h, be careful that you're identifying h and k both correctly in this case, because they're both going to kind of have that effect of, well, I see x minus 3, so then h is going to be 3. Or I see y plus 1, so then k would be a negative 1. It's always going to appear to kind of be that opposite of what you see, because the negative or minus signs are built into the actual format to these equations. So as we practice graphing these or practice finding these components to it, it is somewhat helpful to kind of go back and remember when you are doing this and you're trying to figure out hk or trying to remember how to find r, remember that you kind of have this form, x minus h quantity squared plus y minus k quantity squared, which equals your radius squared. So you kind of see it here. And if you don't see it, it's because the values that we're going to see here are actually unnecessary to be written, so that's why they're not in here. But an x squared is actually an x minus 0 being squared. X minus 0 just being x, so that's why you only see an x squared there. Plus y minus 0 quantity squared. And so you start to identify these pieces of, okay, I see h, I see k, I see the r squared over here. And so when you find the actual center, that's going to be, again, h comma k. But when you find the radius, what you actually have here is, remember, in that last spot on the right-hand side of the equation is r squared. So to find the radius then, you're going to have to take the square root of that on both sides to get r all by itself. Remember with this, because we're talking about a length, we only really care about the principal root. You don't care about the minus when you get the plus or minus from taking square roots. And so we're only going to focus on the principal root, so the radius would just be 2. So when you go to graph this, what we talk about usually is this idea of you should graph the center first. So 0, 0, right here. And then after that, what I like to do is take the radius and kind of count in the four directions, left, right, up, down, from the center, and count 2 units to find out where the edge of the circle is going to be. So, for example, if I count 2 units to the right, that would be an edge of the circle there. If I count 2 units up, that would be the edge of the circle. 2 units to the left, edge of the circle. 2 units down, edge of the circle. And so now you can kind of at least use those 4 points to help guide your drawing of the circle. So again, just take advantage of that and be able to draw the, most accurate circle you can. Try and do your best. And that's it. So again, finding the center, finding the radius, and once you have those 2 things, then you can graph them by just putting those 2 pieces together. So again, same thing here. We're going to look for our center. Once we find our center, we're going to look at the radius. And after that, put it together and graph. So again, if we look at our equation, x minus 0 inside that x squared, plus this y minus 2, and again equals this 49, you can identify h, k, and you got your r squared over here, remember? So you got your center at 0, 2. So again, you see minus 0, you see minus 2, but it's actually just 0 and 2 for the center. And then our radius squared is this 49 on the right-hand side. So take the square root of both sides. And we get our radius is 7. So again, same idea. Go over to your graph. You can plot the center first at 0, 2. 0, 2 right here. Your radius is 7 units. So if I count to the right, 1, 2, 3, 4, 5, 6, 7. If I count up, 1, 2, 3, 4, 5, 6, 7. And if I count to the left, 1, 2, 3, 4, 5, 6, 7. And down, 1, 2, 3, 4, 5, 6, 7. Again, just helps you kind of guide yourself through drawing the circle. It doesn't have to be perfect, but try your best. A few more slides here, then we'll be done. Again, not trying to change it up too much on you all. Same idea here, just identifying. You got h, you're going to have k here, and you have your radius squared. So again, this is one of those examples where, yes, you can identify h as a positive 4, as you see that x minus 4, and you can identify k as a negative 1, because again, you see y plus 1, which would be y minus a negative 1. So that's why you see the plus in there. Okay. R squared, again, is equal to this 9. So if I take the square root of both sides, my radius is just a 3. So go find it on the graph. 4, negative 1. 4, negative 1. And let me clear that in. There we go. And we use the radius of 3 to count off in each direction to help us graph. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And draw your circle. Okay? So identify h and k. Figure out your radius by solving r squared equaling that number. Get yourself an approximate radius or the exact radius and graph. Put those together. So sometimes you're going to be in these situations where they're going to give you an equation, but they're not quite in the right format in order to actually see hk and figure out your values. So when you are given things like this, you're going to have to do a little bit of work here to get it in the correct form. So what I mean by that is when we look at our actual form and you look at how it was written before, it's x minus h quantity squared plus y minus k quantity squared equals r squared. There's no values out front here multiplying these parenthesis groups other than just 1. And so in this one that we have here, we're first going to have to get rid of these 2's. And so if I divide everything on this side by 2, not just the first one, but everything gets divided by 2. Okay, it's as if I'm dividing the entire left-hand side by a 2. I have to do it to the same on the right side. So yes, whatever I do to one side, I have to do it to the other. So this would leave me with x plus 1 quantity squared plus y minus 3 quantity squared equals this value of 20. So, identifying h and k, h would have to be a negative 1, k would have to be a positive 3, and r squared would equal 20, and so when you take the square root, you might have to do some simplifying here. Square root of 20 would be a square root of 4 and a square root of 5, which would just be a 2 radical 5. Okay? So you got your center at negative 1 comma 3, and you got your radius of 2 radical 5. Okay? Just for the sake of knowing, so when it's time to graph, we can actually make somewhat of an accurate graph of this. This is approximately, and again, you still need to keep things exact, and we'll emphasize that again and again here, but this is approximately like 4.47, so it's about 4.5 for the radius. Okay, so you go over to your graph, negative 1 comma 3, negative 1 comma 3, and again, this radius of ours is about 4.5, just shy of that, so 1, 2, 3, 4.5 to the right, 1, 2, 3, 4.5 going upward, 1, 2, 3, 4.5 to the left, and 1, 2, 3, 4.5 downward. So again, kind of get your circle drawn, get an idea of what it's going to look like, and there you go. So again, even if your radius doesn't come out to be a perfect, nice little whole number, you can still approximate its length. You can still simplify radicals just like you did before in other questions. So bringing back those skills and making sure you can still do it. So then the last thing is being able to write an equation. So again, before we're kind of given information, or we're looking at an equation, then we have to pull out the information to be able to graph it. Kind of going backwards, we're given in some information, some specific characteristics about the graph or the circle, but now we're trying to build an actual equation. And so some of the problems are pretty straightforward as far as, you just kind of fill in, the pieces that you're looking for. As far as if I'm going to fill in this equation, x minus h quantity squared plus y minus k quantity squared equals my radius squared, you can identify, okay, well, I got h, I got k, and I have my radius here. So fill those things in where they go, and then see if you can simplify anything or see if there's anything that needs to be changed or fixed. But if I got x minus h is a negative 4, that would be plus 4 inside this first parenthesis group. And plus then y minus k is 8, so y minus 8 quantity squared. And then taking this idea of I'm squaring this radical, 3 radical 5 is my radius, and that over on the right-hand side would be r squared. And so simplifying mostly has to do with simplifying that r squared. So remember how to square these things. Remember, squaring is taking it times itself. So even if you did 3 radical 5 times a 3 radical 5, that'd be a 9 radical 25, which would be 9 times 5, which would be 45. And so there's your equation. So if you can actually figure out the center and the radius, like this problem gave us, if you can figure out that information, then you'll have all the pieces you need to fill in those 3 letters, h, k, and r, and you can figure out the equation for your circle. Now, sometimes it's going to be a little bit trickier, okay? And so with this one, just want you to imagine this is, and again, I think the only way to really kind of imagine it is to do kind of a quick little sketch of this. But if you had the center of the circle is out here at 12, 0, and if you had a point that is on the circle back here at 7, negative 2, right here, that means your circle is something like this. So your center is there at 12, 0. A point that is on your circle, or a point that your circle passes through, is 7, negative 2. And so you got to figure these things out. Well, I have h and k for the center. I'm not worried about that. But now it's about finding the radius. And so there's a distance from the center point to a point on the circle, that would be the radius. And so there's two main ways I think that people tend to kind of go through figuring this out. Either you can revert back to the good old days of doing a distance calculation. You can do a distance calculation of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You can do a distance formula with the 2 points you're trying to find the distance between. Okay, so you could plug in your center and plug in the point on your circle. Or, truthfully, my preference here would be if I kind of zoomed in on this graph and said that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I had my center here at 12, 0, and I had my point on the circle is at 7, 7, -2. 1, 2, 3, 4, 5, 6, 7, -2. Figuring out the distance from this point to this one is the same as solving for this right triangle and using the Pythagorean theorem, where this was 2 units difference there, and this was 1, 2, 3, 4, 5 units here. And so to figure out your radius, it is the exact same process you did back in your geometry classes. A squared plus b squared equals c squared. In this case, my radius is the hypotenuse. 4 plus 25 equals my radius squared. 29 equals my radius squared. So if I take the square root of both sides, the square root of 29 is my radius. Okay? And it doesn't have to be like, perfectly, worked out as far as a whole number, but now you can fill in the equation. X minus h was 12, quantity squared, plus, when k is 0, you don't need to write y minus 0 quantity squared. It could just be y squared. And then if I'm squaring this radius of square root of 29 squared, well, all that's going to do is just square the square root on that 29 away. So it's just going to be 29. So sometimes you might have to pull out some kind of older tricks like the distance formula or the Pythagorean theorem to figure out one of your actual values, like the radius. So the last problem here is a problem that puts together a few things, but combines some of the actual things we talked about earlier in the trimester with completing the square. And so when you're looking at a problem like this, find the center and the radius of the circle. Hint, you will need to get the equation in the correct form in order to see the center and the radius. Okay? And so one of the things you need to work on is figuring out how in the world would I get something like this, where there's an x squared term, a y squared term, there's a singular linear x term 6x, and there's a singular linear term of negative or minus 10y. There's no parentheses, and so I have to kind of create, these parentheses that you see. We're going to have to create these parentheses here in order for this to be in the correct quote-unquote form. And one of the ways to do this is by completing the square. So remember this process we talked about earlier on, where if I wanted to take this and rewrite it as a binomial squared, I had to do this process called completing the square. So if we just focus on the kind of x portion of this, x squared plus 6x plus what would be completing the square? And we said it is the middle term, the b term, cut in half, b over 2, and then squared. That's what we're going to have to add on here. So if I take 6 divided by 2, that's 3, and I square that, that would be a 9. That's what needs to be added on there to complete the square, so I could, in a sense, factor that part of this into an x plus 3 times an x plus 3, which is x plus 3 quantity squared. So that was completing the square, and what we said was if I added 9 to this side of the equation, I was going to have to add 9 to this side of the equation as well. And you can basically do the exact same thing here for the y's portion of this. If I have a y squared minus 10y, but I'm completing the square to figure out this missing blank term that I don't have here, I would have to take the middle term, negative 10 divided by 2, and square that, which would give me negative 5. Squaring that would be 25. So I have to add 25 to this, which is going to allow me to factor this and rewrite this as a binomial squared. So two numbers that multiply to be 25 and add up to be negative 10 would be negative 5 and negative 5. So there's my binomial squared. I did add 25 on the left-hand side along with that plus 9 from the first one, so I'm going to have to add another 25 to this side here. So in total, the left-hand side changes to these binomial squares, x plus 3 squared and y minus 5 squared. The right-hand side is a 15 plus a 9, which is a 24, plus a 25, which is a 49. And so now it's in the correct quote-unquote form, and you can see things a lot clearer. You can see that h is indeed a negative 3. You can see that k is a positive 5, and you can see that r squared equals 49, therefore r would be a 7. So your center, negative 3 comma 5, and your radius is a value of 7. So taking some time here, okay, this example here, this last one is probably one of the harder problems you would have on circles. Most of them are just, can you talk about and figure out things like the center, the radius, could you graph them? And that's going to be the big things we want you to walk away from in this lesson. So take a look at the worksheet. Let me know if you have any questions. I'm planning to be back Wednesday morning, so if you have any questions, feel free to come in early Wednesday before school and go over some problems, ask some questions, go over some clarifications you need. But other than that, we'll see you all later, and hopefully I'll see you on Wednesday.